All right, we are given 2 points, and we're told that they're on a graph of a function that satisfies a differential equation. We're asked which of the following must be true. Okay, so they ask a lot about max and mins and point of inflection. So what's likely to happen here is I probably need to find dy dx at each point, and I probably need to find d squared y dx squared at each point. That's basically the gist. So let's start with the easy one. I already have dy dx, so let's go ahead and do that first. So dy dx evaluated at -1, -1 is going to be a -1 squared plus a -1, which is 1 minus 1, that's 0. Okay? Dy dx evaluated at 1 comma -5 is going to be a -1 squared minus a 5, so that's a -4. Okay, so this is not an extremum, right? This is not a max or a min. So you can cross off any answers that involve a max or min at 1 comma -5, right? It is likely to be answer C or D, because what's likely happening here, and I can't be sure, but what's likely happening is that they want me to do the second derivative test. So I could do the second derivative test, right? Let's try using the second derivative test at this spot to see if we have a max or a min. Well, in order to do that, I really need the second derivative. So I know dy dx is an x squared plus a y. That means the second derivative is dy dx squared, right, equals 2x plus dy dx, which I can leave as dy dx if I want, or I could rewrite as 2x plus x squared plus y. Doesn't really matter. Okay, once I know that's my second derivative, let's go ahead and apply it to that point that we know is a spot where the graph is level. So d squared y dx squared at -1, -1 would be a 2 times a -1. Plus, we already know this nets to be a 0 because we already saw that at that point dy dx is 0. So it's a -2, meaning it's less than 0. So what we're seeing is at the point -1, -1, the graph is concave down and flat. That's a max. So we go up and say, hey, there's a max at -1, -1, and let's see which answer that is. Oh, hey, there you go, local max at -1, -1. And that's it.